Hello everyone. On this video we will be going over solving quadratic equations by factoring. Okay, so starting off we're going to give you the standard form of what a quadratic equation looks like. Okay, so it has the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers. And of course, a does not equal 0. Okay, so for example, x squared plus 2x plus 1 equals 0. That's a quadratic equation. 3x squared plus 7x plus 2 equals 0. That's a quadratic equation. And etc., and so on. Okay, now the principal idea behind solving quadratic equations by factoring is what we call the zero factor property. Okay, and the zero factor property is if a and b are real numbers, and we know that a times b equals 0. Uh-oh, don't need that comma there. Should put the comma. Here we go. Then a equals 0, b equals 0, or both. Okay, so what that's saying is, if you have two numbers and you multiply those two numbers to get 0, then one of those numbers will have to be 0, because 0 times anything will be 0. So a could equal 0 because 0 times b will be 0. B could equal 0 because a times 0 is 0. Or both of them could be 0. 0 times 0 equals 0. Alright. Okay, so let's move on to our first example. And if you're still writing, feel free to press pause. Alright, so let's say, for example, if you want to solve, let's say x minus 3 times x plus 1 equals 0. Okay, now when you have a problem that's already factored like this, it's really straightforward, because all you have to do is set both to 0. Because remember, a times b equals 0 means either a equals 0 or b equals 0. So that means x minus 3 can equal 0, because 0 times whatever this is will equal 0. Or x plus 1 can equal 0, because 0 times whatever this turns out to be will still equal 0. Okay, so if x minus 3 can equal 0, or, excuse me, x plus 1 can equal 0. Okay, so if we add 3 to both sides here, we end up with x equals 3. And if we subtract 1 from both sides here, we end up with x equals negative 1. So your solution set is x can equal negative 1 or 3. Alright, so what about, we have the example, we wanted to solve 12n minus 4 times 6n minus 2 equals 0. Alright, so really this is the exact same thing. As long as it's already factored for you and it equals 0, you just set both to 0. Okay, so you have 12n minus 4 equals 0, or 6n minus 2 can equal 0. Either one of those will make this correct. Okay, so if we subtract or add 4 to both sides here, we'll end up with 12n equals 4. So if we divide both sides by 12, we get n equals 4 over 12, which simplified would give us 1/3. N equals 1 over 3. Okay, because remember that 12 equals 4 times 3. So those 4s would cancel out, and you get 1 over 3. Okay, so now we'll go ahead and solve the second one. We add 2 to both sides here. So we have 6n equals 2. So if we divide both sides by 6, we get n equals 2 over 6. Again, if we remember that 6 is equal to 2 times 3, those 2's would cancel out. So you get n equals 1 over 3 on this side. Okay, so for this one, your solution set would just be 1 over 3. Because that is the only solution for that problem. Alright, so let's say for our next example, we wanted to solve 4w times 10w minus 7 equals 0. Okay, so for this one, I want you to go ahead and press pause and work this one out on your own. Alright, so assuming you have everything worked out, we're going to go ahead and solve this one. Once again, it's already factored. It's equal to 0. So we set both to 0. So we have 4w equals 0, or 10w minus 7 equals 0. So move that up a little bit. Okay, so for this one, we divide both sides by 4. We end up with w equals 0 over 4. And 0 divided by anything is just 0, so we have w equals 0. And for this one, we add 7 to both sides. We have 10w equals 7. So if we now divide both sides by 10, we have w equals 7 over 10. Okay, so your solution set is 0 and 7 over 10. Okay, now those are usually the easy circumstances where you have to solve quadratic equations where they're already factored for you. Most of the time you will have to do the factoring yourself. Okay, so let's go ahead to our example of that. Okay, so for example, let's say if we wanted to solve a squared minus a minus 20 equals 0. Okay, now the previous examples, they were factored for us already. With this, we have to do the factoring ourselves. Okay, so if you need a refresher on factoring, just go back to the factoring videos. Okay, but for this one, we just need to factor a squared minus a minus 20. Okay, remember there's nothing in front of the squared term, but we know here that b is equal to -1 and c is equal to -20. So we have to find two numbers that multiply to equal our c, and those same two numbers add to equal our b. Okay. Now in this case, -5 and +4 works, because -5 times 4 is -20, and -5 plus 4 is -1. Okay, so that one works. So that means your a squared minus a minus 20 will factor into a minus 5 because it's negative, and a plus 4. Okay, so altogether our a squared minus a minus 20 equals 0 becomes a minus 5 times a plus 4 equals 0. Okay. Now if you notice, that looks just like our first couple of examples. So once we get it factored, we just set both to 0. At least both of those factors, not to 0. Okay, so that means a minus 5 can equal 0, or a plus 4 can equal 0. Either one will make this true. Okay, so if we add 5 to both sides here, we have a equals 5. And if we subtract 4 from both sides here, we have a equals -4. So your solution set is -4 and 5. Okay, x can equal either one of those, and it would be correct. Alright, so how about we go to our next example. Alright, so for example, straighten that out, there we go. What if we wanted to solve 3a to the third power minus 18a squared plus 24a equals 0. Alright, now remember, it has to be in the form ax squared plus bx plus c equals 0. That's our quadratic form. Okay. Now, since we have an a to the third power, the good thing about it is we have an a in each term. And we also have a multiple of 3 in each term. So all we have to do is factor out 3a from each term. Okay, so if we factor out 3a times what would give us 3a to the third power? That's 3a times a. Okay, so 3a times what will give us -18a squared That's minus 6a. And 3a times what will give us 24a? That's plus 8. And again, if you want to double check, just distribute, and you should end up with exactly what you have here. 3a times a is 3a to the third. 3a times negative 6a is negative 18a squared. 3a times 8 is 24a equals 0. Uh-oh, I got my squared. There we go. Okay, now for this one, we're just going to have to factor, because this 3a is already factored, but we still have to factor this part. So if we factor a squared minus 6a plus 8. Okay, so this, you want to always remove the greatest common factor if possible. Always remove the greatest common factor if possible. Okay? Because a lot of times, if you just factored out the a, you had 3a squared, then you'd be tempted to use the a times c method, and that's a lot more work. You'll get the same answer eventually, but it's a lot more work. So you always want to factor out the greatest common factor of each term to see if you can avoid using the a times c method and get your answer a little bit faster. Okay? Uh-oh, move that up some. Here we go. Okay, so if we're going to factor a squared minus 6a plus 8, a squared minus 6a plus 8, we know that b is equal to negative 6 and c is equal to 8. Okay, so that means we have to find two numbers that multiply to equal our c, and those same two numbers add to equal our b. Let's straighten that up a little bit. There we go. Now in this case, negative 4 and negative 2 works, because negative 4 times negative 2 is positive 8, and negative 4 plus negative 2 is negative 6. So that means your a squared minus 6a plus 8 becomes a minus 4 times a minus 2. Okay, so to break it all down, you have 3a times a squared minus 6a plus 8 equals 0. We factored this part, so now that becomes 3a times a minus 4 times a minus 2 equals 0. Okay, now once we have it all factored out, set all factors to 0. Now that works whether you have 1 factor, 2 factors, 3 factors, 10 factors, doesn't matter at all. Once you have it factored out, you just set them all to 0. So that means 3a can equal 0, or a minus 4 can equal 0, or a minus 2, uh-oh, straighten that up a little bit, can equal 0. Okay, so for this one, we divide both sides by 3. We end up with a equals 0 over 3, or a equals 0. For this one, if we add 4 to both sides, we end up with a equals 4. And for this one, if we add 2 to both sides, we end up with a equals 2. Okay, so our solution is 0, 2, and 4. A can equal any of those values, and it will make your original equation true. All right. So let's go ahead to our next example. Okay, so let's say, for example, we want to solve 12x squared plus 28x equals -8. Okay, now remember, you want to solve it in standard form. Standard form of a quadratic equation is ax squared plus bx plus c equals 0. Okay, so really all we have to do here is just add 8 to both sides. Because once you add 8 to both sides, you have 12x squared plus 28x plus 8 equals 0. Okay. Now with this one, your greatest common factor, you can't factor an x out of each term, but you can factor a 4. Okay. So that would give us 4 times 3x squared plus 7x plus 2 equals 0. Alright. And you can always double check it by using the distributive property. 4 times 3x squared give you 12x squared, and so forth and so on. Now the good thing about this is, as soon as we factor out just a number, we didn't factor out a variable. Okay, but if we factor out just a number, we can just divide both sides by 4. So if we divide this side by 4 and this side by 4, these two will cancel out. So we have 3x squared plus 7x plus 2 equals 0. Okay, so that kind of helps us to where we don't have to deal with such large numbers. Okay, now we can't factor out another value, and because we have a value in front of the x squared, we're going to use the a times c method. Okay, so with the a times c method, we know that a is equal to 3, b is equal to 7, and c is equal to 2. Okay, so the first thing we have to do is, in the a times c method, is find a times c. So a times c is 3 times 2, which is 6. Okay, so we have to find two numbers that multiply to equal our a times c, and two numbers that add to equal our b. So in this case, 6 and 1 works, because 6 times 1 is 6, and 6 plus 1 is 7. Okay, now remember, with the a times c method, as soon as you get to this part, you replace your bx term. So you replace 7x with 6x plus 1x. you have your 6 and your 1x, just replace the 7x. So that means this now becomes 3x squared plus, and instead of 7x, we have plus 6x plus 1x plus 2, can't forget that, equals 0. Okay, so now the left side, we just factor by grouping. Remember, when you factor by grouping, you take the 4 terms, you break it down to 2 subterms. And then you find the greatest common factor from those. So this one you can factor out of 3x. So you have 3x times x plus 2. And for this one, you can factor out a 1. So you have plus 1 times x plus 2 equals 0. Okay. Now, as long as your binomials match, you can factor those out. So you have x plus 2, and you can go ahead and cross those out. And whatever's left goes in the other binomial. So you have 3x plus 1 equals 0. Okay, so we're good there. We have it all factored out. So now we go to the part where we just set both to 0. So you have x plus 2 equals 0, or 3x plus 1 equals 0. Alright, so for this one, if we subtract 2 from both sides, we get x equals negative 2. And for this one, if we subtract 1 from both sides, we end up with 3x equals negative 1. Divide both sides by 3. We have x equals negative 1 over 3. Okay, so your solution set is just negative 1 over 3 or negative 2. Again, x can equal either one of those, and it will be true. Alright, so let's go to our next example. Bring the paper down a little. Okay, so let's say, for example, if we want to solve 6x squared plus 24x equals 0. Let me kind of straighten that up a little bit. There we go. Okay, 6x squared plus 24x equals 0. Okay. Now with this one, even though we have just the 2 terms, we can still solve this. Okay, so first we just factor out 6x from both terms. So if we factor out 6x, (6x) times what gives us 6x squared? That's 6x times x. And 6x times what gives us 24x? That's 4. And again, you can double check it by distributing to make sure you factored it correctly. Okay, so now this is all factored out. We do just like we did before. We set both to 0. Okay, so we have 6x equals 0, or x plus 4 can equal 0. Again, either one would work. So if we divide both sides by 6 on this one, we end up with x equals 0 over 6, or x equals 0. And if we subtract 4 on both sides here, we get x equals negative 4. All right. Now, let's say instead of factoring out the 6x, what if we only factored out x? Okay, let's say you forgot to factor out the 6. Okay, so if you factored out just the x, that would be x times 6x plus 24 equals 0. Okay, again, once it's factored, we just set both to 0, just like we did up top. That means x can equal 0, or 6x plus 24 equals 0. Now remember, if we factored out just a number, we can divide both sides by the number. You can't factor out an x and then divide both sides by x. Okay, you can only do that when you factor out just a numerical value. Okay, when you factor out a variable, you actually have to leave that variable there and then factor out. I mean, not factor out and then set to 0. Okay, so here we have x equals 0 and 6x plus 24 equals 0. X equals 0 is already solved. You don't have to do anything with that one. So if we subtract 24 from both sides here, we have 6x equals negative 24. So if we divide both sides by 6, we end up with x equals negative 24 over 6. 6 goes into 24 4 times, so we end up with x equals negative 4. So either way, you'd get the exact same answer. All right. So let's go on to our next example. Okay, so let's say, for example, we want to solve negative 8n to the third power plus 26n squared minus 6n equals 0. Okay, which is pretty similar to, which example was that? The example on your 4th page. Okay, so if we look at this example that we did previously, it's pretty similar to that one. Okay, so what I want you to do is I want you to press pause and try to solve this one on your own. Alright, so I'm assuming you've already pressed pause and you've worked this one out. So let's go ahead and verify your answer. Okay. Now remember, we want it in standard form for quadratic. So if you look closely, you see that we can actually factor out a negative 2n from each term. Okay, and the reason I did a negative 2 is because I want that first term to be positive. It just makes things a little bit easier. Okay, so if you did factor out just a 2n, you could still solve it. It just makes things a little more difficult with that negative floating around. So factoring out a negative 2n turns that first term positive. Like I said, it just makes it flow a lot better. Okay, so you have negative 2n, and that leaves us with 4n squared minus 13n plus 3 equals 0. And again, you can distribute to double check. You should end up right back where you started. Okay, unfortunately, we can't get rid of that value in front of the square. Okay, so that means we have to apply the A times C method. Okay, so it's a little more work, but it's no biggie. So we have to apply it just to this portion here. Okay, we don't have to apply it to this one. That's factored out, so we can apply here. Now, we could have applied it if we just factored out the n, but that would make that a very large problem because your b would now equal 26. So your A times C would be 48. So you have to find two numbers that multiply to equal 48 and add to equal 26. That's a lot of calculating to do. So you want to factor it out because now doing the A times C method on this problem, on this quadratic, is a lot easier than doing it if those numbers didn't get knocked down a little bit. Okay, so you always want to find that greatest common factor. Okay, so we know on this one, A is equal to 4, B is equal to negative 13, and C is equal to 3. Okay, so of course the A times C method means we have to find A times C. So A times C is 4 times 3, which is 12. So we have to find two numbers that multiply to equal our A times C. And those same two numbers add to equal our B, which is negative 13. So in this case, negative 12 and negative 1 works. Because negative 12 times negative 1 is equal positive 12. And negative 12 plus negative 1 equals negative 13. Okay, so this equation becomes negative 2n times 4n squared. Because remember, with the A times C method, we now replace our B term, so negative 13n, with negative 12n plus, or you can put minus instead of plus negative. You can make that minus 1n. Okay, so you have 4n squared minus 12n minus 1n, and you still have that plus 3 equals 0. Okay, so now this part we factor by grouping. Okay, so remember, when we factor by grouping, we get the 4 terms, and we just make them 2 smaller terms. Uh-oh, don't want to write that down just yet, so it's not going to be too crammed. So we'll do this first. So these 2 terms, we can factor out a 4n. So we have 4n times n minus 3. And these 2 terms, you can factor out a negative 1. Okay, so when you factor out your negative 1, you get n minus 3. Okay, now once we know that our 2 binomials match, we can factor those out. So we get, and remember, we're just doing this part right now. So we have n minus 3. Those 2 cancel out, and what's left goes in the other binomial. So we have 4n minus 1. Okay, so this all together, just gonna zoom that right on there, that gives us negative 2n times, and we factored this part already, so that's times n minus 3 times 4n minus 1 equals 0. Okay. So even though the A times C method is a little more work, it's not too bad once you have the process down. Okay, so again, we set each factor to 0. Okay, so that's negative 2n equals 0, or n minus 3 equals 0, or 4n minus 1 equals 0. Okay, so if we divide both sides by negative 2 here, we have n equals 0. We add 3 to both sides here, we have n equals 3. This one, if we add 1 to both sides, that gives us 4n equals 1. We divide both sides by 4. We have n equals 1 over 4. Okay, so any one of those would make this true. All right. Okay, so let's go to our next example. Okay, so what if we wanted to solve 4x squared minus 28x equals negative 49? Okay, so this one is pretty similar to our previous example. 12x squared plus 28x equals negative 8. Pretty similar to that. So what I want you to do is then press pause and try to solve this one on your own. Alright, so assuming that you have pressed pause and solved this one, you have to remember your standard form. So your standard form is ax squared plus bx plus c equals 0. So this one, we just have to add 49 to both sides. So that would give us 4x squared minus 28x plus 49 equals 0. Okay. Now we can do the A times C method if you want, but it will be a lot easier if you did it using perfect square trinomial. Okay, so remember the perfect square trinomial, a squared plus 2ab plus b squared equals a plus b squared, and a squared minus 2ab plus b squared equals a minus b squared. Straighten up that a little bit. There we go. Now, because we have a minus here instead of two pluses, we're going to be using this formula. Okay. The first thing we have to do is notice that our first term and our last term are both perfect squares. Okay, so we know that 4x squared can equal 2x squared. And we also know that 49 is equal to 7 squared. So if we rewrite it, instead of 4x squared, we make 2x squared. That middle term, we're going to leave that blank for right now. And at 49, we'll make that 7 squared equals 0. So that means for these two to match up, this middle term has to equal 2 times a times b. Okay, and that 2 times a times b has to equal 28x. Now we see here that our a is equal to 2x. And our b is equal to 7. So 2 times a times b is equal to negative 28x. We can just plug our a and b right into that formula. Okay, so we have 2 times a, which is 2x, times b, which is 7. 2 times 2 is 4. 4 times 7 is 28. 28x, so we have our 28x. Okay, so it matches. Okay, so that 28x matches that 28x. So all we have to do, since those match up, is our a minus b squared is just equal to 2x minus 7 squared, since our a is 2x and our b is 7. Okay, now since we have 2x squared minus 7, that just becomes, let me kind of break down each step so make sure I didn't lose anyone. 4x squared minus 28x plus 49 equals 0. That becomes, because remember, we just factored that part. 2x minus 7 squared equals 0. Okay, so 2x minus 7 squared is just 2x minus 7 times 2x minus 7 equals 0. Okay, so remember it's factors, so we set both to 0. Oops. So really, if you have 2x minus 7 equals 0 or 2x minus 7 equals 0, you only have to solve it once. You don't have to solve it twice if it's the same thing. Okay, so here if we add 7 to both sides, we have 2x equals 7. And if we divide both sides by 2, move that up, we will have x equals 7 over 2. Okay, which is the only solution for that quadratic equation. All right. So remember, you have various methods to factor your quadratic expression. Again, if you're a little bit rusty on it, feel free to go back to the quadratics video to go over all of the methods to factor them. Okay, so let's go on to our next example. Okay, so what if, for example, we wanted to solve x times 3x minus 1 equals 14. Alright. So with this one, remember you want it in standard form. So your standard form, ax squared plus bx plus c equals 0. Okay, so some of you might look at this one and go, oh, it's already factored. I can just go right into it. You can't, even though it's factored on this side, it doesn't equal 0. Okay, remember, it has to equal 0. Okay, so the first thing you want to do, 3x minus 1 equals 14, is you want to go ahead and distribute. Get rid of those parentheses. So that makes it 3x squared minus x equals 14. Okay, so if we go ahead and subtract 14 from both sides, we have 3x squared minus x minus 14 equals 0. Okay, now this is what we're going to solve. But what I want you to do is go ahead and press pause again. Try to solve this one on your own. Alright, so hopefully you've solved this one. And we're just going to go ahead and verify. So instead of minus x, I'm going to make that minus 1x. Just for visual purposes. If you left it as minus x, you're good. Okay, so here we see we have a value in front of the squared term. So we're going to use the a times c method. Alright, so we see here that a is equal to 3, b is equal to negative 1, and c is equal to negative 14. Okay, so we know that a times c is equal to 3 times negative 14, which is negative 42. So we have to find two numbers that multiply to equal our c, which is negative 14, and those same two numbers add to equal our b, which is negative 1. Okay. So in this case, negative 7 and positive 6 work. You have negative 7 times 6. Oh, sorry, negative 42. I don't know why I put 14 there. We got for the a times c method, we have to find two numbers that multiply to equal negative 42. Sorry about that. And negative 7 plus 6 is negative 1. Okay, so our next step on the a times c method is we're going to replace our b term. So we replace negative 1x with negative 7x plus 6x. Okay, so 3x squared And instead of minus 1x, we have minus 7x plus 6x. Or you can put plus 6x minus 7x. Both would work. Minus 14 equals 0. Okay. So now, you remember you do your factor by grouping. Kind of separate those a little. Okay, so if we factor by grouping, we take those 4 terms and break them down to 2 smaller terms. Smaller groups. Okay, so for this group, we can factor out an x. So we have x, which leaves us with 3x minus 7. Okay, now for these two, we can factor out a 2, which again leaves us with 3x minus 7. And that would be equal to 0. Since we have our matching binomials, we can go ahead and factor those out and run a quick line through them if you like. And what's left goes into our next binomial. So we have x plus 2 equals 0. Okay, so once again, we set both to 0. So that gives us 3x minus 7 equals 0, or x plus 2 equals 0. Okay, so here if we go ahead and add 7 to both sides, that gives us 3x equals 7. Divide both sides by 3, we have x equals 7 over 3. And this one, once we subtract 2 from both sides, we have x equals negative 2. Okay, so those are your solutions to that problem. Alright, so hopefully this video made sense to you, and I will see you on the next video.